This week on Cloud's Law, we're going to play crime scene investigator. Ever wish you could play crime scene investigator? Having helped on a few investigations back in my paramedic days, it isn't nearly as exciting hunting for evidence as it is on TV, but it turns out this is one of the most fun and interesting security domains for those of us who are security professionals. We're a long ways away from covering incident response, where we go into this in more depth. But over the next two labs, we'll play out a little scenario and use it to combine multiple skills together for where we are today. Our primary objective is to learn about something called snapshots. But to make it more interesting, we'll learn how to use those snapshots as part of a security investigation. Now, we're a long way from covering incident response to any level of depth, and I want to emphasize that in a real investigation, we're always going to focus on IAM and CloudTrail before we ever worry about resources, which is where snapshots are going to come into play. But it's still a handy skill to learn. It's used by every response team out there on the planet, and it's the kind of thing that we can use as part of our ongoing education. So today we'll take the framing of a forensics investigation and use it to learn about EBS volumes and EBS snapshots and a little bit about cross-account sharing. And in our next lab, we'll learn how to use those snapshots in an actual investigation. Now, although your career is taking a major turn if you're hunting for hair and blood samples in a cyber attack, digital forensics is a major domain in the information security profession and one with some very highly specialized skills. More skills than what I've needed the few times that I've had to do evidence searches back in my paramedic and rescue days. I did find the finger, but there was like a lawnmower incident. Forensics covers a lot and is essential investigations. Just like those CSI shows, we hunt for the evidence left behind. Just like in those CSI shows, we hunt for the evidence left behind by an adversary. It's also important to preserve that evidence in case you eventually need that for law enforcement or for bringing in the lawyers. Of forensics, there's disk forensics or driver storage forensics. And this is the one that's used in tons of investigations, particularly those in your on premise in your data centers or employee laptops. And in the physical world of laptops and hard drives, to collect our forensics, we use special hardware that has something called write blocks in place, so we can copy out the contents of the flash drive without modifying what's stored on there and destroying the evidence and contaminating the scene. Now, we don't have physical hard drives in AWS. I mean, Amazon does, but we use virtual hard drives. And these are called EBS or elastic block storage. Because in the cloud, we can't just call them virtual hard drives. I don't know, something about not using simple names. Our instances can have multiple EBS volumes, multiple elastic block storage volumes, which are the hard drives or the virtual hard drives that are attached to them. And one of those is always going to be the boot volume. And we've been creating those with every one of our instances. We just haven't looked at them yet. And an important feature of EBS is snapshots. An EBS snapshot is a point in time copy of an EBS volume. These snapshots are incremental, meaning that only the blocks on the device that have changed since your last snapshot are saved. These snapshots are stored redundantly in multiple availability zones and using Amazon S3 for high durability. Now, you can't go into S3 and see them, just know that that's the service that's backing them in terms of where they're stored. They can be used to create new EBS volumes. So the snapshot is the copy, but then you can create a new volume and load it up with the data in the snapshots. And this is incredibly useful for backup and disaster recovery purposes. Or it's a good way to migrate data across Amazon regions or Amazon accounts, because these snapshots can be shared with other accounts and they can even be made public. And oh, yeah, we've got a lot to say about making them public, and we're going to get to that one later. Now, while the initial snapshot of a volume copies all of the data, future snapshots only copy the bits that have changed. And this is really commonly done in virtualization. It's not like Amazon invented this capability. It just makes it more efficient in terms of how they're stored and how you move these around. Now, snapshots are awesome for security because we can make a copy of an instance's drives and we can't change it. Snapshots can't be deleted, or sorry, can be deleted, but they can't be changed. They're what we call immutable. When you take a snapshot, you can't go in and edit that snapshot. We can make copies of them, we can create new ones. But if you think about that idea of those write block copying devices to copy a hard drive out without making any changes to the drive so we know it's exactly what it was supposed to look like, that's effectively what happens when we take a snapshot of a storage volume. The storage volume isn't modified and the snapshot itself can't be changed, and everything is all tied together in a bow and correlated with each other, and all that activity is logged. We can then load up this data and use it in our analysis tools for an investigation. Now, snapshots can also be shared with other accounts or even made public unless you block it, and that's part of a future lab. This is a bit different than some of the other cross account sharing things like where we set up IAM because it doesn't happen within IAM and it doesn't happen within a resource policy like those S3 bucket policies that we talked about way back when in earlier labs. It's actually an attribute of the snapshot itself. It's a bit weird if you've been working in AWS for a while, but remember that snapshots were a very early capability of EC2 and of EBS, and I think they were released before IAM or resource policies even existed. Now, there's a big security implication here because if you think about it, unless you put something in place to block it, anyone with the ability to make the API call modify snapshot attribute can potentially share a snapshot with another account or potentially even make it public itself. And you can see what that actually looks like in the blog post. I've got a little snippet of what the JSON is. Snapshots are really popular with attackers for data exfiltration because in a less mature environment, it's easy to miss the permission to put restrictions around modifying those attributes or to put restrictions on which accounts can be shared with. Attackers used to just take snapshots and make them public. I mean, that's the first attack I did when I did my very first AWS hacking demo at DEF CON about 12 years ago. But these days, they tend to share it under other Amazon accounts under their control. Now, again, there's ways to deal with all of this, and in future labs, we're going to talk about it, and especially in terms of preventing snapshots from becoming public. But for our purposes, we actually want to allow snapshot sharing across accounts because we're going to use that for the right reasons and sharing them to the right people. And in our case, it's going to be how we transfer out our forensic copy from our compromised account into our security team's investigative environment. Okay, I threw a lot at you. And so the key points that we just need to worry about for today, and we're going to get more into some of the additional sharing and stuff later, and how to actually do the investigation. For today's purposes, just remember that EC2 has these virtual hard drives, and they're known as EBS volumes, elastic block store volumes. A snapshot is an immutable and unchangeable copy of that EBS volume. It's great for backups and it's great for migrating data. And then snapshots can be shared across accounts by modifying just an attribute of the snapshots. Now, we can use this for our forensic analysis, but attackers can also use it for data exfiltration. All right, let's jump in the lab and let's just see how all of this works together. As I mentioned, we broke this lab out into, or this scenario out into two different labs. For today's lab, we're going to deploy a VPC and an instance into our workload account. That instance has a little surprise associated with it. We're going to use that as an excuse to take a snapshot, and we're going to share it with our security audit account. And I'll go into why we picked that account and what we're using it for a little bit later. Okay, with that, let's start off in our sign-in portal. As you can see, Amazon's making some updates here to kind of tell you different ways of using the sign-in portal. But in our case, we're going to ignore that, and we're just going to go to test account 1 and administrator access. And from here, we're going to go directly into CloudFormation. Now, you can get it from the blog post. I will show it briefly on screen as well, but let me paste in. So this is lab41.template. I know I've got my creative naming scheme here. Let's click next. And then we're going to name it, I don't know, CSI. Okay, so that way, in case you have anything else running in your environment still, you'll know what it is. And click next. And then scroll down, click the little checkbox because we're going to create our usual SSM role. Don't worry, we're not doing anything nefarious, despite the criminal nature of this lab. And then we're going to click submit. And this is going to launch the VPC and launch an instance. So as usual, I'm going to go ahead and pause for a moment and let this run its course. All right, usual 3 to 5 minutes there. My stack is created complete. Now, by the way, you're going to want to make sure your access portal is still open on another tab. That is the default, but we're going to have to go back to that in a minute to get the ID of the account that we want to share with. Okay, so now we're going to go into EC2 itself. And with an EC2, I'm going to show you how to figure out the storage volume, the EBS volume associated with an instance. So if I go in here and you can see that I did name it hacked, I've got the one instance that's running. And we're imagining in our scenario that somebody has compromised an instance and we need to do a snapshot and we need to share it with our investigative team for forensics. So that's that setup here. And if I click on it and I go to the details, if I go to storage, storage is going to tell me what the ID of the storage volume is. Technically, we could detach this hard drive, like unplugging it and plug it into a different instance. It really is just that flexible, very similar to hard drives. I'm going to show you quickly the easy way to get to this volume, which is where you just go to instance, you go to storage, like we are here, and then you just click on the volume ID, and then that's going to take us to the volume. That's how you know the volume that's associated with the instance. Now, if you scroll across, then you can also see that it will also, under attached resources, it will tell you if you just go straight into storage volumes. So let's say I take that filter off. I just go into volumes. I can scroll across to attached resources and I'll see if it's attached to an instance. So those are two ways that we can track down which volume is associated with which instance. And you could actually search on this window here on the instance ID if you needed to try and find it. Now, taking a snapshot, let's actually look at what a storage volume is. So we'll click on the storage volume itself. And you can see a bunch of information here. Now, you'll notice that it said when the storage volume was created and the snapshot ID. So this is the snapshot that instance was based off of, which is your AMI. That's right. Amazon Machine Images utilize snapshots themselves. And we could actually copy that ID out. So it's very different anytime you load a storage volume with data at all, which includes a boot volume. It's going to have an ID associated with it because it was actually based on an existing snapshot. And that's actually the lab we're going to be doing next week. Is we're actually going to create a storage volume with the snapshot of this volume. So this that it was created from is just the raw operating system. All right. So we'll go back to volumes. We'll click that checkbox and we're just going to go to Action, Create Snapshot. And so we have to give it a name and we're going to make up a name. We're going to call it CSI Incident 1, something that we can keep track of. So this is the description to make it easy because trust me, I have lost track of many, many snapshots over the years. We can apply tags. There's no encryption set up in this account, so we don't need to worry about that. And we'll click Create Snapshot. Now we need to wait for that snapshot to finish created. So you can see up at the top here, successfully created snap ID from volume. But let's go click on snapshots. And while it's still in a pending state, notice there's this little drop down here. And if I go owned by me, I can go to private snapshots. We only have that one, but this is going to be something to keep in mind later. Or we can go to public snapshots. Oh my goodness, what are all of these? So there are tons of snapshots that are actually made public. In fact, I had an incident once and I used public snapshots to go ahead and share it. And if you want to have fun, you could actually build some AMIs based on some of these or launch some instances or attach these as storage volumes. I can guarantee you that a lot of these are probably mistakes or things that were not meant to be there. Quite a few of them are associated with AMIs, with those machine images, Amazon machine images that other people are using. Snapshots are a way of sharing data with other organizations. There's a lot of uses for snapshots, including public snapshots, but obviously they have a risk. All right, enough talking about that. Let's go click on Owned by Me. I have my one snapshot there, and let's click on it. And so here's all the snapshot details. We'll tell you what volume it came from, Now, here's a warning for investigative purposes. If you terminate the instance, that storage volume goes away. So if you actually need to go back to that storage volume for any reason, you definitely don't want to terminate it. So there's some references here. I remember I told you it was all referenced and traceable, but that doesn't mean you're not going to end up tracing it back to something that doesn't exist yet. So you want to be careful about that. We're going to go down to our share permissions, and this is where we're going to share the snapshot with our investigations account. Now, let's go back to our AWS Access portal. And although we have some security accounts, we have the security audit and the security operations. I could put this technically in either one. In most of the places when I set up an environment, I actually set up a specific incident response account just to do what we're going to do here today. And in this case, though, let's just throw it into our security audit account, which is where we observe things. It could go in operations. Reality is that's not the account I would use for real. As I mentioned, I would use an incident response, but we do need this account ID. So let me see if I can work the user interface here. Select just that account ID, and I'm going to go ahead and copy that because I'm going to go into the snapshot, and we have shared accounts, and we're going to go ahead. It's done as private. Let's go ahead and add an account ID. And it warns us the snapshot's unencrypted, so anybody can read it. And then we're not going to make it public, but we are going to add account. And we're going to paste in this account ID within our organization. I had a trailing space there so for my copying, so I need to make sure that's out of there. Click add. And then we click modify permissions. Okay, that's it for the lab today. We learned how to take a snapshot. We learned what an EBS volume was. We learned how to identify that EBS volume, what instance it came from. In the next lab, we're going to jump over to that security audit account, and I'm going to show you how to load up that snapshot, and I'm going to put you on the investigative trail to see if you can find the little bit of evidence that I actually hid in the instance. It was too much to all fit in one lab, so we had to break it apart. This one's nice, short, and tight, but hopefully this gave you a better understanding of how storage volumes work, of how instances always have storage volumes with them, and how we can take snapshots for those near instantaneous backups. And next week, we'll actually see what those look like now that we've learned how to share them cross account. That's it. Have a great week. One thing I almost forgot is we can actually delete out all of our other resources and leave just the snapshot. So let's go ahead and do that. And even though I mentioned that reference and you wouldn't want to do this way in a real environment, just because of our cost savings and keeping things clean, let's go back to services, cloud formation, click on our CSI stack, and then go ahead and delete it. And again, don't do this for real, but it does work for our particular lab, the way we have things set up, just to keep our long-term costs down.